Okay, everybody, this is chapter 1, right? Let's look at it. These are the objectives. Describe the basic features of an algorithm. And this is important. Algorithm is very important. So we will talk about that, okay? Explain how hardware and software collaborate. And and then we will compose and run a simple Python program. So let's talk about the two fundamental ideas of computer science, okay? Computer science focuses on interrelated ideas, right? Two of the most basic ones are algorithm, and information processing. So what is an algorithm? An algorithm is really a step-by-step instruction that accomplishes a task. So if you think about it, when you want to subtract two numbers, that's a task, right? You want to subtract two numbers. What do you have to do to accomplish that task? You have to follow the steps. And even if you do them, you say 9 minus 5 in your head, you actually are still following these steps, which are write down. You don't write down, but you visualize if you do a simple subtraction. Let's suppose you are doing a more complicated one and you need to write down. So you write down the numbers with larger number above, smaller one, right? And the digits column aligned from right. And then step 2, start with rightmost column of digits and work your way left through the various columns. You see, it tells you first you start from right, and then you work your way to the left. And write down the difference between the digits, and so on, right? Borrow one from the next column, etc. And step 4, if there is no next column to the left, stop. Otherwise, move to the column to the left and go to step 3. So you keep doing this until there is no digit left on the left. So this is an algorithm. This tells you how to perform subtraction. So what is an algorithm? Once again, it is a step-by-step, a series of step-by-step instruction that accomplishes a task. Okay. Oops, let's go back. Okay, that is an algorithm. Any questions? Can you think of another algorithm? Give me, can you think of an example of another algorithm? Am I recording? Yeah, I am. Okay. Can you think of another?
A cooking recipe?
Yes, exactly. A cooking recipe. You follow the recipe, you go step by step, make the dough and put it on the sheet, or whatever you need to do, right? You follow it step by step from the beginning, and then you can make a cookie, you can bake a cookie. So that is an algorithm. And in computer science, whatever you do, you really follow an algorithm. And the computer will follow those instructions and will give you an outcome, right? If your algorithm is wrong, the computer will give you the wrong outcome. If it's correct, it will be correct. So the computer doesn't know anything. It follows your algorithm. Okay, that's why it's very important. For example, if you want to calculate how many, what's the total cost of your purchase, what do you do? If you go to the store and you bought a lot of things and you want to calculate the total cost of all these things, what do you do? Anyone?
Add them all together, calculate tax.
Okay, add them all together. Before you add them all together, think about it. When you do a computer program, you have to be very detailed and precise. So first you need to get the price.
Get the
right?
price for each item.
Yes, you need to get the price for each item and you need to add them together. And then what do? Oh, that's it. That's it, right? Yeah, that will be the total cost. What if you want to calculate the average cost of each item? You will have to get the price of each item. And then what do?
You have to add them all together.
Add them
and then
together
divide by the
and-
number of items.
Yes, and divide them by the number of items. That will give you the average price. So that is an algorithm. Okay, any questions, everybody? Okay, so the computing agent is a human being. You see, this is why I'm not letting you do, I'm not requiring you to do the reinforce, what is that called? Reinforce and this part. That's why I'm not unit 1 reinforce. I'm not requiring you to do that because it uses a lot of terminologies that it's not as important. Some terminologies, algorithm is extremely important, but computing agent not, but it means a human being. Okay, but in that reinforced quiz, it will ask you, what is a computing agent? So that's why I'm not requiring you to do that. Okay. Sequence of steps that describe each of these computational processes is called an algorithm. Basically what I said, and they are just interchangeable, right? As long as you understand it is a series of instructions, step-by-step instructions that accomplish a task, you're good. That is an algorithm. Okay, features of an algorithm consists of a finite number. This is also very important, finite number of instructions. If your instructions are limitless, then it's not an algorithm because it cannot be accomplished, right? It has to be finite, the number of instructions. And each individual instruction is well defined. I follow the instruction, I have to know what to do. Action described by the instruction can be performed effectively or be executed by a computing agent. Okay, any questions, everybody? No? Okay. Describes a process that eventually halts, and this is also very important. You know, it has to be finite and well-defined, and eventually your algorithm will stop, right? Once it arrives at a solution. If it doesn't stop, your computer will go into a loop and it never comes out. It doesn't stop. Your computer will eventually crash. So it has to halt after the solution is arrived at. And one algorithm has to work for that general class of problems. For example, when you say calculate the average of each item, okay, I can buy apples, pear, I can buy fruit, a variety of fruit, and you have to calculate the average cost using that algorithm. I can buy a set of clothing, and you have to be able to calculate. I can buy different things, fruit, produce, clothing, and computer and everything. Your algorithm has to work. So this is what it means, a general class of problems. It cannot only apply to one set of data. Okay? It cannot apply to only one set of data. It has to apply to that category of problems. Computers can be designed to run a small set of algorithms for performing specialized tasks. And that is more of the operating system, so we don't have to talk about that. Okay, information processing. Information is also commonly referred to as data. So you hear people say data-driven. Nowadays, when you make a decision, we always say data-driven decision. That means you gather all the data and you make a decision based on that, right? For example, now we decided to stay home and do this class remote. How did they come at that conclusion? Because they look at the cases, the COVID cases, look at the hospitalization rate, and based on that data, they decided, okay, we need to have students stay home. That's what data is, right? So people use information and data interchangeably. Actually, data and information are two different things. If you think about it, data is raw data. Information is processed data. So what is raw data? Raw data is something like if you get a 90 on the test, that's raw data. Your points, your score is 90, right? Okay, you get 70 on the test. That's raw data. Information is you process that data and get the information. So how do you process that data? 70 means nothing. That means raw data means nothing unless you say this tests, if you get everything correct, you should get 100 points. Now you got a 70 out of 100, that's a pass, that's good. That's the information. But 70 itself is not, it's not information, it's data. But if this test has 200 questions and 200 points total, but you got 70 points, you know, that's not a pass, right? That's not good. So that is the information you are getting. That's the difference between data and information if you want to delve into that. But nowadays, because a lot of people who are not computer savvy are also using these terms, and so we begin to use them to replace one another. You can call information data, you can call data information. I want to make that clear here. Okay. In carrying out the instruction of an algorithm, computing agent, which is a human being, manipulates information, starts with input. You see, that is actually the data. Transforms information according to well-defined rules, transforms data actually according to the rules and produces information or output. So give me the input, I will process it, and then I will give you the output, right? So give me the data, I will process it, and then I will give you the information. Okay, the algorithms that describe information processing can also be represented as information. Okay, computer scientists are in discover how to represent many other things, such as, you know, how do you, so when we say input, we don't mean only numbers, we mean all other things as well. Your speech is input, it can also be output. Video can be input, it can also be output. So it really depends on the problem you are solving, right? So that is algorithm and information. Information is so important. Some people, some scientists will say information is the future. The future is all about information, right? It's very scary. And some people will say information has its own life almost. It spreads itself around. It's a philosophical and physical physics question, but it's very interesting. So algorithm, step-by-step instruction, right, for the computer, and information is processed data that informs you to make a decision. Modern computer system has hardware and software. Give me a piece of hardware, everybody. Give me an example of hardware. Monitor, right? Monitor, keyboard, CPU, memory, all those hard disk, all those are hardware. Software is really a program. And how do you write a program? A program follows an algorithm. So software is a program written in a programming language. In our class, we are going to write programs with Python. Any questions? So hardware is the tangible things you can touch, and the plastics and the metals. Software is the program, right? Okay. Any questions, everybody? Hardware, okay, we already talked about this. Memory, this is the RAM, random access memory. It's a chip, right? It has a size. And without memory, your computer will not be able to process things. Central processing unit, that is the CPU, that is the brain of the computer. It processes things. And input and output devices. Input devices, your keyboard, your microphone, they are input devices. Output devices, your monitor, your monitor, your printer, right? Those give you the output. Okay. Computers can all, and this is telling you that you can also see the ports. If you look at your computer, you see all those ports. You plug your USB in, that's a USB port. And if you have landline, you put your cable in, plug your cable in, that's a network port. I'm sure there are network administration people who are majoring in network administration. You know that better than other students maybe, but there are different ports. Those are hardware also, right? Okay. You know what? I will let you read this and see if you have questions. I'm going to pause my recording. Nowadays, you hear people say shortage of chips, and that's why your used car is worth so much more. Cars are more expensive because there is a shortage of chips, and those chips are the CPU chips, right? The processor. Okay. The random access memory is inside the computer, and the secondary memory is a separate one. It's the hard disk. It's a separate piece of hardware in the box. It's not on the motherboard. It is connected to it. So that's why it's called external. Okay, and your USB is an external secondary memory also. We call this a first memory, primary memory. This is called primary memory. It's because the CPU works with this memory directly. The CPU doesn't work with the second memory at all. Okay, I shouldn't say at all. I should say it works with the second memory or your hard disk indirectly. So that's why this is called primary, because it connects with the CPU. The CPU works with it directly. Okay. Now let's look at this memory. This is what I added yet last night. I want to make sure to explain this. So that's what it's added. Okay. If you look at this model, this is a model of computer memory. Okay. And each block, each one is called a cell. And that is a location. When we say there is not enough memory, we mean there are not enough cells to store things. So basically, this is a place that you can store your data or information. Okay, so each 1 or 0 is called a bit. A bit is the acronym for binary digit. So we call that bit, okay? Each 8 bits, 8 of them are formed as a byte. We call that a byte. So bits and bytes. 1 byte has 8 bits, and therefore it can represent 2 to the 8th different things. That is where memory comes in, right? If you have 1 byte, you can store 256 different things. Okay, do you understand that? Okay, for example, let's just say you have 1 bit. This is 1 bit. How many different things can you represent with 1 bit? Do you think?
256.
No, 1 bit, not 1 byte.
One.
1 bit.
Oh, 1 bit, sorry.
1 bit. How many things can you represent?
2.
Two different things. It can be 1 or 0, right? So 1 bit can only store 2 different things. A byte, which is 8 bits, can store 256 different things. That means ones and zeros can change and you can form 256 different patterns. So let's go on. Suppose you have 2 bits. How many different things can you represent with 2 bits?
4.
4, exactly. You know, you can represent, okay, we say 1 can represent red, 0 and 0 can represent black, for example, and 1 0 can represent yellow, and 0 1 can represent blue. So it can represent 4 different things with 2 bits. That's what this means. Okay, with 8 bits, you just change the positioning of each ones and zeros. The permutation is the combination is 256. That's what this means. Any questions? Okay, then so you know what a byte is, right? So when we say a memory location stores things, we simply mean it changes the pattern of ones and zeros to represent different things. Okay, so if this location stores 1 1, we say that's red. If it stores 0 0, we say that's black. That's what we mean when we say it stores things. Okay, each byte is numbered, so you can see 1, 2, 3. Actually, this has 2 bytes. Okay, but we will just call that memory location 1, 2, 3. Okay, that byte number is the address of that byte. So when you say address of memory location, it's the byte number. In this model, each cell has 2 bytes, and therefore each memory address or cell can store 2 to the 16th different things. And that's a lot. I don't remember, I think it's like that. You can do a calculation if you have a calculator, but it's roughly that many, maybe. Okay. So you can also combine several bytes. Okay, you can not just 2 bytes, you can combine 4 bytes and call that a cell. And that will be able to store 2 to the 32nd different things, right? So together to represent a very large value. For example, in Python, each integer requires 4 bytes. So a bit is just 1 or 0. And you combine 8 of them together, that's a byte. Each byte has a number, that is its address. And because 1 byte can only change to 256 different patterns, we sometimes need more. Most of the time we need more. So we combine them together, either as 2 bytes or 4 bytes or 8 bytes sometimes, put them together. To use them. That way we can represent many different things. Any questions, everybody? Okay, so a program stored in computer memory must be represented in binary digits. So everything in computer is binary. No matter what you enter on your keyboard, no matter what string, what text you type, it's all converted, it's all represented in binary digits. So it's all ones and zeros, and that is called machine code. So the machine can only recognize ones and zeros. Okay. So once you enter, a loader takes a set of machine language instructions as input and loads them into the appropriate memory locations. This is the inner working of the computer. So the machine language will be loaded to the correct memory location. And the most important example of system software is a computer's operating system. Okay, the operating system is software, right? It's a program, a bunch of programs together. It is software. That's why Microsoft is called Micro and then Soft, because it produces operating system, and operating system is software. Okay, some important parts of the operating system: file system, user interface, right? It manages your file system. It manages how you interact with the computer. It provides you with a user interface. Otherwise, how do you give the computer instructions without an interface, right? So that is the function of an operating system. And then we have application software. So you have system software, you have application software. Application software is the software that we, the end users, use, such as web browser, word processor, Excel sheet, database managers, and etc. Your games, your video game is an application software. Okay, so operating system manages the system, and application softwares allow you to actually do what you want to do. The system software operating system provides the environment. It manages and maintains the environment so that you can accomplish what you want to do using a specific application software. Any questions? I shouldn't say an application software because software is not countable. So use an application. When we say an application, it means application software, a piece of application software. Any questions, everybody? Okay, so how do you make software? We write them, right? And we use high-level programming languages to write them because it's impossible, almost impossible, to write a program using the machine language, which is ones and zeros. You cannot write instructions using ones and zeros. Regular people cannot. So we designed high-level programming languages so that we can write them. High-level programming languages resemble English, and you know why English is the most. Is it? Maybe not, but it's the most popular, one of the most popular languages. I'm thinking Chinese, but even Chinese people, when they write software, they use English. They use C++ or Java. So if you don't know English, it's really difficult to learn programming, I think. Okay, so we use a text editor to write the program, and then that program is translated into executable code, which is binary, okay? And then the translator, before it translates, it will check to see if you have syntax errors. Remember, we are using a language. A language has grammar, it has syntax. You have to follow that grammar and syntax strictly. Unlike in everyday communication, when you talk to me, even if you use the wrong grammatical format, even if you have syntax errors, I can kind of understand you when it's not too nuanced, right? But with computer language, if you even make one small error, a typo, a space, etc., the computer doesn't understand you because it doesn't comply with the syntax rules or grammar. So it's very important to remember to be syntax correct. So if you have syntax errors, you have to go back to the text editor, edit, correct your program, and ask it to retranslate. And if you still have syntax errors, it doesn't translate for you. It will ask you, you have to go back and re-edit and then translate. Once you are free of syntax errors, the code will be translated into executable code, which is ones and zeros. You know, that is executable code. That's only understood by the computer. Okay. If no errors are found, the program can be executed by the runtime system. So this is make it into ones and zeros. This is actually execute the ones and zeros. Okay, might execute program directly on the hardware. This is when you have assembly language, it doesn't need translation. It will directly, almost doesn't need translation. It will directly execute. But if you write it with high level language, it needs to be translated. Okay. By an interpreter or virtual machine. This is for Java, virtual machine. Java uses virtual machine. Interpreter is used by Python. Any questions?
Someone asked a question in chat.
Okay. Just know that when I talk, I don't have time to check the chat. So let me know when you have a question in the chat. Yes, thank you. Is this what people consider bugs? Yes, bugs has two types. One is syntax errors. That's a bug. But actually, when you have a syntax error, it's the easiest bug because you can go back and correct it. It's easy to fix a syntax error. When we say bugs, it's usually a not runtime error, but mostly it's a logical error, a logic error. Okay, for example, when you want to calculate the average price of each item, instead of doing a division, you do a multiplication. That would be a bug. You know, you run your program and it runs smoothly. It gives you a result, but it's a wrong result. So that is the most dangerous bug, right? So I said this just now. I said syntax errors, you can call them bug, but they are very, very easy to fix. Usually when we say there is a bug, it's usually the logic error because syntax errors are the easiest ones to fix. Logic error is difficult. You have to find the logic error. So that's the most difficult thing. Yes, to answer your question, is that a bug? Yes, but most often we refer to logic errors as bugs. Okay.
Thank you.
And, any other questions, everybody? Okay, so this is the process, right? Text editor, you write your program here using high-level programming language, and then the translator will translate it. But if you have errors, you come back to redo the edit, and then you go there to translate. And if it is correct, it translates, it goes to the runtime system to produce the output here. For at runtime, you might have errors also. We call that runtime error. If you have runtime error, it gives you a crash. It crashes the system. And when you run it, user inputs things. And if you have a runtime error, it crashes. If it's correct, it goes to produce the result. Okay, that is the process. So you write your program. The program is checked to see if there is syntax error. If there is syntax error, it cannot be translated. You have to re-edit. And once it's free of syntax errors, it goes to runtime system. And the user has the time to input, has the chance to input data. And then it will produce result or it will crash because of runtime errors. Okay, any questions, everybody? So that is the precursor to Python. We briefly discussed the computers and hardware, software, system software, and application software, and the process of writing a program and running a program, right? That's what we just went through. And we especially discussed the binary numbers and the memory address. So now let's come to Python. Okay, so Python was invented in 1990s, and Java was invented in 1995. So they at the same time, in the same decade at least. Okay, early 1990s, and Java was invented in 1995. So Python is a high level. What do we mean when we say high level, everybody?
You mean that it's written in a way that's easily understandable for us, but wouldn't be able to be executed by a machine the way it's written?
Okay. So yes, and when we say high level, what does it look like?
Like
Which
written English?
English, yes. Okay. English. Okay, it's very much like English. So high level, general purpose programming language. When we say general purpose, we mean it can work for all kinds of problems. Okay, for solving problems on modern computer systems. Python is an interpreted language. Interpreted language, what this means, when we write a program, you will see that. It simply means Python will interpret each instruction to binary and run it line by line, versus a compiled language. The other one is compiled. Okay, a compiled language, on the other hand, will compile the whole program. If you have 100 lines of code for that program, it will compile all those lines into an executable file and run it. Python, on the other hand, it will just translate the program line by line. And as it translates, it runs. So it's a whole versus pieces. To download Python, you just go to that website. Let's see. Okay, so here, and you can download. See, it's right here and download. It's really easy. Okay, and then you just follow the instructions to run, right? To install. I'm trying to see if there is one for Mac. I don't think so.
I sent one.
Yes.
I think
Oh, Macintosh. Okay, so you have.
if you
Okay.
go back to the beginning, it gives a link to it.
Okay. I just use my school computers for schoolwork. I use my Mac for my personal information, so I haven't downloaded Python for Mac. So this is, if you have a Windows, this is how you can download. Oh, Mac, right here, right here. Okay, everybody, that is that. That's how you download and install. So should we go on, or do you want to have, let's see. Okay, to find your Python, you can simply type in Python, right? You see, mine is 3.8. I downloaded last semester, I think. So you can see it's right there, Python. Okay, so you can click on that. And that is the shell. The other one you talked, I was talking about is Python IDLE. So you simply type IDLE, and when I type I, it already came out. So this is the other version. Was that what you were talking about just now? Maybe, right? So let's look at this first. Okay, this is called the shell. I double clicked, I think. You can put it on your taskbar so that you don't have to do it each time, right? So you just search. Once you install, you just search Python, and then right click and pin to start, or pin to taskbar. This way you can have it there. I'm sure you know that. Okay, so everybody can start. Okay. So now let's, you all have this. So this is the shell. Okay. And the other one, did I start with that one? Is it still, I'm not sure if it is. Let me do the IDLE. Mine is right here, so I will start it. So this is the ID. Oh, this is the shell also. Okay, let me do a search. This is the scanning. It stays here somehow. Okay, Python IDLE, and I will. You can also pin it, right? I will start it. Oh, this is, yeah, this is. I need to start a file. Okay, new file. So this is these are the two different ways that you can write. This is the shell. Okay, this is called the shell. That means you type something and for example, hello, and it will show you immediately. And this is the prompt. This is called the prompt, right? It's the command line. So whatever you type, it will immediately execute. Versus this IDLE will allow you to write multiple lines of instructions and then you run them together. So that's the difference. When you have multiple lines of code, when you want to write a program, a complicated program, or simply a program, you want to do it here in this environment because it allows you to do that. Here, whatever you do, immediately it will give you the result. It is line by line. So that's the difference. Okay. Any questions? Okay, so now let's look at this. We discussed this. We discussed this already, right? How? Where am I?
We're under Python, I think like the first or second page of Python.
Yeah, okay, we are here. So simple Python expressions and statements can be run in the shell. You see, that's what I was saying, right? Simple Python expressions and statements. You can run them in the shell because it's fast. You don't have to create a file and save and then run. You can just type it in and it gives you the result. But when you want to write a program, a complete complicated program, you want to use the IDLE. Okay. So when you launch the shell, there are two ways, obviously, just now, right? I forgot about this. IDLE also gives you the shell. So you can use this shell, the system shell. You can also use the IDLE, which gives you the shell also. This is the shell, you see, right? But you can also create a file. And that will be the script. We call that a Python script, okay? So shell is useful for experimenting with short expressions or statements consulting the document. Okay, so that's what that is for. Let's use the shell first, okay? You can use this shell or you can use this shell. Either one works. They are all shell. It's called Python shell, right? So let's do a simple one. You just type hello and you see it prints out. It echoes what you just typed. It tells you that's what you typed, right? And we can also say print. Let's type that print, which is a function. Notice the uppercase, lowercase. Okay, this is lowercase, and all functions are in this pink color in my environment. You can change your environment. You can go to options, configure it, and change the environment. Okay, print, and then you have to have the parenthesis. Okay, and within it, whatever you want to print onto the screen, you have to put it in the double quotes. That's, remember we talked about syntax. That's the syntax, very important. So now we can say hello, right? And then you press enter, and notice the difference. Here, you are not saying print, you are not calling the function. You're just saying, what is this? And you type this string. And then the system tells you that's what it is. It's a string. Here, you are saying, print that out. Make it more formatted and nice looking. So print hello. And this is the actual text that's printed. Any questions, everybody? Print your name. Print your name on the screen. So now you can print things, you can display things, display a string of characters on the screen, right? You can print 1, 2, 3, 4. That's a string. This is not a number. When you have double quotes around something, that becomes text, that becomes string. So it prints out 1, 2, 3, 4. Remember, that's not a number because I have the double quotes. So basically, whatever you want to print out, you have to put it within the double quotes. I can do this, and then hello, and then, and then it will print out like that, right? Whatever is within the double quotes will be printed out. Okay, so let's look at this. Programs usually accept inputs from a source. Oh, did I? Let me see, is this? Yeah, okay. Process them and outputs results to a destination in terminal-based keyboard and terminal display. So we use the keyboard to input, and this is the terminal display. It shows you the result, right? In Python, inputs are Python expressions or statements, outputs are the results displayed in the shell. Okay, so this is the inputs, and that's the display, the result, right? This is also the input, that's a statement. We talked about this already. Let's look at this one. The following example receives an input string. Okay, here I need to be more detailed because this is a little bit more complicated. So this receives an input string from the user and saves it for further processing. Let's look at this. This is saying input. This is a function, everybody, just like print. This is a function. This is saying, this is calling the function input and telling the user what to do. Okay, so it's telling the user what to do. Enter your name. And this is what you will see. That is from that, right? Okay, enter the name. So this input is a function. And then the user enters the name, in this case, this name. This is the author's name. And that name is stored in this. This is called a variable, a memory location with a name. So remember just now we discussed memory locations, bytes, right? Cell number is the address. But we as human beings in a high-level programming language, we cannot remember all the byte numbers. So we use a symbolic name. We call that a variable. That is the name for a location. It may be byte 100, it may be byte 200, but that's the name that represents that memory location. So you are saying, enter your name, and then you assign that name to that location. So now when you reference that location, the system will get what is stored in that location and display it. And when you print, it will print this. Okay, so let's do that. So if we want to get the name, we want to first declare a variable so that whatever the user enters, we can store it, we can save it for further use. So I'm going to say first name. Use the equal sign. Okay, that's actually called the assignment operator. And we call this function, instead of print, which displays things, input will get the user input from the keyboard. So input, and then you tell the user what to do. So I will say, enter your first name. Okay. This is a line. This is an instruction, right? They're saying, enter your name, and I will store that name in the variable named the first name. And so this is the execution, right? This is executing. You see here, that's the execution. So here, this is the execution of that instruction above. And you just enter your name. And then press enter. And that's it. So let me ask you this question. Where is William right now? Not physically in our class. I don't know. I don't think we have a William in the class, but where is William?
It's stored in the first name variable?
Yes, exactly. This William is stored in this first name variable. So now if you reference that first name variable, if you mention it, oh, did I?
You misspelled first.
Oh, first name. Yes, you're okay, everybody. This is very good. Thank you. This is a syntax error. See, I said first name, right? I misspelled. It should be first name. So the system gives you a syntax error and it doesn't execute anything because it cannot translate this. So it says name, first name is not defined. That means this variable name doesn't exist. So you will correct it. And it shows you that's what is in that memory location named first name. If you say print first name, it will print. Okay, so let me explain this. Why don't I use double quotes here while I do use double quotes here? Anyone who wants to explain that?
Because you're referencing the variable as opposed to
A string.
like, yes.
Yes, very good, Alina. Yes, here I'm referencing, I'm saying, print the thing that is saved in that location. Print the thing that is saved in that memory location. Here I'm saying just print whatever I give you, right? And this is print whatever I gave you also, but what did I give you? I gave you a memory location. So the system needs to go to that memory location and get the content in that memory location and print it out. Any questions? Okay, get your last name and print it, everybody. Ask yourself. So I ask you to enter your last name, right? So you can say last name, always have a variable, have a location to store things. And you call the function input and say, what's your last name? It should be a question mark. Always end it with the double quotes. So what's your last name? That's my last name. And so now you can print the last name, right? And you can print first name also. You can use it because it's saved there, right? You can keep doing that. So that's what we meant when we say declare a variable, have a variable, and so that you can use it, you can save the information for further use. So we declare this variable and we got the information into it, and now we can use it here also. We can use it again and again, because whenever you use it, you're going to that memory location. The system is going to that memory location and get the content there. It's saved there, right? Unless you redo it and you change things. So if I redo it, I will say first name, everybody look at what I'm doing. Input would change your first name. Very arbitrary, and you enter Bill. And now when you say print first name, it's changed. Okay, that memory location will remain the same. Your content will remain the same until you change it. So here I'm changing it. You see, I'm getting some new value into that same memory location. The previous content, William, is overridden and the new content goes there. And so when you reference that variable again, that's the new content. You just entered, right? Okay, any questions? I'm giving you this, what time is it? I'm giving you this to see that this, what's wrong here, everybody?
Enter the first number. Oh, it's missing a quote at the.
Yes, it's missing a double quotes. That's why it says syntax error. End of line while scanning string literal. End of line. There is nothing more, but you don't have the quotation marks. So that's the problem, okay? So make sure you have that. And then you enter the number, okay? And then you say enter a second number, and you enter a second number, and you add them together, it becomes this instead of adding. The reason is when you use this input function, everybody listen, this is important to remember. When you use the input function, whatever you input, it's saved as a string into that variable. It's saved as a string, okay? So even if you enter a number, you think you are entering a number, but it's saved as a string in num1. That's why when you add those two strings together, it gives you this. Okay, so let's do that. I want to make sure I'm recording. Am I? I am. Yes. Okay. So so here, let's say num1. That's a variable, right? Equal to input. Some of you look at this and you think you have an extra space. This doesn't matter. This extra space, this white space doesn't matter. But sometimes if you do this, that matters. That's two different words. It doesn't make sense to the system. It doesn't recognize it. So this space matters, okay? That's what I meant when I say if you have an extra space. But this extra space doesn't matter because you have a word that's correct there, and then you have this symbol that's correct. So in between, however many spaces, it doesn't matter, okay? So input, enter a number. And then you think you are entering a number. So everybody, why are they together? How do I prevent that problem?
Prevent what problem?
Here.
How do you prevent that?
Yeah, you can see enter a number, and when I enter the number, it's immediately after number. It doesn't look good. So what do we do?
Just go in between the 3 and the R, put a space, or?
Yeah. I mean, there should be a space there, but How do I correct that error? Not error, but
Oh,
just,
because you didn't put the what is it called, a colon? You didn't put the colon after enter a number at the top.
okay, okay. Okay, yes, that's correct, right? So what I was trying to tell you is that whatever you put inside this quotation marks will come out that way. So if you don't have a space, there is no space. If you don't have a colon, there is no colon. So whatever you want to do, if you put a space there, right? Now it's better. So you can put a colon there. That's what I meant. Okay. So now if I enter num1, you see it's a string. It has the single quote. It's not a number, it's a string. So to summarize, this input gives you a string. It gets a string and stores it into a variable. It doesn't give you a number. Any questions? So I can do here, I can do num1 plus first name. Okay, and you can see that is combining the two strings together, and that's called a string concatenation. That means you are concatenating, you are combining them together using this plus sign. Okay, so any questions, everybody? Okay, so let me think. Let me stop. Pause. Okay, so you saw that just now. I told you that that's a string, right? You cannot use it as a number. I need to close that and just use a new one. So you get a string, and that's not a number. So if I say num1 equals to input, enter a number, and you enter a number, and that is not a number, that's a string. We talked about that. When you look at it, it's a string. So how do you make this into a number? Okay, how do you make this into a number? If you look at this, we have all these functions. We have float and int. Int will convert a string into an integer. Float will convert a string into a float. A float is simply a decimal number, okay, a real number. And this will convert it into a whole number. And you already know this, right? Input we learned, and print we also learned. And notice that when you use print, if you want to print multiple things, you separate them with a comma, okay? And you can add two strings together. You can concatenate them. So those are the functions, and let's look at them. So if I can convert it into a number, I can do this, okay? I'm going to show you. Num2 equals to int num1. So remember, num1 is what? It is a string. I'm using the int function to convert it to an integer, just to make sure I am recording. Okay, so I am using the int function, which is this one we just learned, to convert that string into a number. And now num2 is a number. If I say show num2, it is a number. Okay, so this int function will convert a string into a number, and the float will convert it into a float, a real number. Okay, that is 56.0. That's a real number, right? Decimal number. This is a whole number because of int. So this is how you use these functions. Okay, so now I can also say print I can print multiple items, num1, num2, 56, 56. Remember, when you print, the string doesn't have the quotes, but remember, this is a string and this is actually a number. Any questions, everybody? You can print different things. Num2, hello, what's up? Okay, that's how you use the string, the print function. When you want to print multiple items, you use the comma, right? Okay, and if you want it to be, an int, you need to convert it into an int. So now if I do num1 plus num1, everybody, what will be the result? Num1 plus num1.
You're just gonna add it around like 30, or I'm sorry, 56, 56. So 5,656, basically.
Okay, it will be 5656, right? Yes, it's a string because num1 is a string, if you remember, right? Num1 is a string. Okay, and num2 converted that string into an int. So now if I do num2 plus num2, it gives you the actual addition result, the sum. Okay, that's the difference, everybody. Look at this one. This will give you the string because num1 is the string. When I convert it here, it didn't change num1. It simply take the value and convert it into an int and make it go into the num2 location. So num2 is an int, num1 is a string. Any questions? Any questions?
One
Everybody?
question.
Okay.
So, what purpose would a float have compared to an integer?
A float, if you want to do pi, it has to be a float, right? If you talk about the price of Apple, you have to use float because integer doesn't cover everything. So more precise. Okay, any other questions? No questions? Okay, so let's do, let's look at this. No, I'm not going to go into that. I will ask you to do this one exercise, okay? Ask the user to enter his or her age and then convert that into an int.
Convert that into a what?
An int, an integer. So I said, ask the user for their age, and then the user enters the age and you convert it into an integer. So I will declare a variable. I use a variable named age and use the input function and just say, enter your age. Okay, that's it, right? And enter, and this is the execution of that statement. And so it's prompting you to enter the age. I will enter 34, and that's it. That 34 was stored, is stored in age, right? So now if you say age, it's 34. Now I want to convert it into an integer. So I'm going to make a new variable and just convert it, that string, into an int. And now when I do age, you can see it's not a string anymore, it's an int. So now I can do addition with it, right? It's 35. But if I simply do age plus 1, it doesn't work because 1 is treated as a number. So you cannot add a string and a number together. Okay, so, but oops, but I can do this. Let me do this. Okay, I can add age And you can see when I try to do age plus 1, it doesn't work because age is a string. When I do this, it works because it's a number, int is a number. So because it's a string, I have to make 1 into a string. And that will be 341. You see the difference, right? So that's the different data types. Any questions, everybody? Okay, I'm going to stop now.